Let's have a look now at electrolysis and how it actually works, how the chemical reactions take place. I'm going to use aluminium bromide for this. Aluminium bromide melts at roughly 90 degrees, so it's something that we could melt in the lab. We could put some electrodes in and we could see what happens here. We obviously have two types of ion in here. We have the aluminium ions, which are going to form aluminium, and we're going to have the bromide ions, which are going to form the bromine. And I've put the full equation at the top. What we usually write is actually something called a half equation. We usually show only what's happening at one electrode at a time. And that's because that's where the chemistry is happening. That's what's more interesting to us. And sometimes we don't actually need to know what's happening at both electrodes. We're only interested in one or the other. So let's just remind ourselves what happens here. If we switch the power onto this circuit, we would end up with our aluminium going, as it's a positive ion, it's a cation, it's attracted to the cathode, which is negative, and the bromide ions are going to be negative, so they're anions, and they're going to be attracted to the positive anode. And that's great. We've split up the aluminium and the bromine. And then I said in the last video, a chemical reaction takes place. So let's have a look at these chemical reactions one by one. First one is the aluminium going to the negative electrode. So what's going to happen here? We've got negative electrodes, and it's negative because it's got a source of electrons. And so because it's got a source of electrons, it's going to give some of those electrons over to the aluminium. And that will cause it to become a neutral atom as opposed to a charged ion. So the negative particles, the electrons, are going to go from the electrode to the ions. Every one aluminium ion can make one aluminium atom. And because they're 3+, we are gaining 3 electrons to do that. And so we write Al3+ plus 3E- goes to Al. Now I know I've got 2 aluminium ions on here. I haven't forgotten about the fact that there's 2 of them, but this is the simplest way that we can write down what's happening. I could write 2Al3+ plus 6E- goes to 2Al. That would be true. But when we're writing these, we try to simplify them down as much as possible, and that's what I've done here. So there they go. They've changed into aluminium atoms. And because they're changing into aluminium atoms, and aluminium's melting point is something about 600 degrees, if we're doing this at about 100 degrees or so, then we would form a solid layer of aluminium around our electrode, which we would be able to see. But that little thing is called a half equation, and that's usually what you're expected to be able to write. Looking at the other electrode now, we've got Br- bromide ions are going to be attracted to the positive electrode. And this is slightly different because bromine doesn't form as Br, it forms as Br2. So we're going to need 2 bromide ions in order to be able to make a Br2. They're all negative, so they are going to be giving their negative charge to the positive electrode here. And so each bromide ion is going to give 1 electron to the positive electrode here. And that means that they are going to be losing in total 2 electrons, 1 per bromide ion. So 2 bromide ions forming bromine molecules, and they lose 1 electron each, so 2 electrons in total are lost. And that might look a little bit like this. So you see the 2 bromide ions make Br2, then we've got 2E-. And there we go, ping, there we go, we've bonded into Br2. And so what we'd see in this case is we would see bromine forming as a gas. It would be hot enough because bromine boils at about 50 degrees C. We're at about 100 here, and so we're going to form a gas, and we would see the bromine molecule zip off as bubbles of bromine gas, which would be orange. So we can see that the chemical reactions happening are due to the movement of electrons. We've lost electrons and we've gained electrons. Now you should remember from year 9 that loss of electrons is oxidation and reduction is gain of electrons. So we can say that we're reducing and oxidizing things here as well. But what I want to focus on just now is where are these electrons coming from and where are they going to? So we said that we have electrons out of the circuit onto the aluminium atoms, and from the bromide ions are going into the circuit. And you should be able to remember from your physics that a circuit is required for electricity because the electrons actually move around it. We have a movement of electrons around the circuit. You can see that the electrons that are lost by the bromide ions are going to go round the circuit, and some other aluminium atoms are eventually possibly going to gain those electrons when they've gone round the circuit, if there's enough stuff in the beaker. Now, the same number of electrons go into the circuit as come out. Okay, and looking at the half equations, that's not immediately obvious here, but just remember that we have 2 aluminium ions for every 3 bromine molecules being formed. So 2 aluminium ions being electrolyzed here would give us 6 electrons going out of the circuit. On the other side, if we had 3 bromine molecules being formed, we would be also putting 6 electrons in. Okay, so that's how it balances out. So at the cathode, cations are gaining electrons, which is reduction from the circuit, and at the anode we're losing electrons, and the anions are losing electrons to the circuit, which is oxidation. And we have electrons traveling through the circuit, and we show the transfer of electrons at 1 electrode at a time using something called a half equation.